everyone, my name is Başak Türker. I'm a PhD student at Paris Brain Institute, and today I'm going to talk about how unwiring functional whole brain connectivity synchronizes between individuals during movie watching. So as a brief introduction, we know that our brain is continually processing information that is coming from the environment, but we also know that only a small part of this information is actually consciously perceived. So in my research, I'm interested in the interplay between the ongoing brain activity and the conscious perception. So I'm investigating how the ongoing brain activity allows or not the conscious perception, and how conscious perception in its turn this time can influence the ongoing brain activity. So today in this talk, I'm going to talk about the second arrow and try to show you that conscious perception can influence the dynamics of the ongoing brain activity. So for this study, we were very lucky. We got some data from Neuromatch's lab. So in the study, we had participants who were in the MRI scanner and watched an 8-minute Hitchcock movie, and they also went through a resting state session. And we had another group of participants who watched the same movie, but in a scrambled version. So the movie was cut into 1-second segments and then shuffled. So when you watch this version, you see all the scenes, but you cannot really understand what's going on. So by using this data, we computed interregional coherence matrices at each time point, so for each TR. So here you see different brain regions, and this matrix tells me how different brain regions were correlated or coordinated with each other. So as I said, we computed these matrices at each time point, so it varies actually with time. And then we used k-means clustering to try to find 4 prototypical brain activity patterns that we can use to classify these different configurations. And these were the patterns that we found. So the first thing that we wanted to check was whether the probability of occurrence of these 4 patterns differed in different conditions, so movie watching, resting state, and scrambled. We saw that the pattern 3 and 4 actually did not differ in terms of probability of occurrence in different conditions. However, the pattern 1 and 2 had different probabilities in different conditions. So for example, you can see the pattern 2 here was more frequent during movie watching compared to resting state and scrambled, and the reverse was true for pattern 1. And then we want to see whether we could find some kind of synchronization between participants in the movie conditions, since they were watching the same movie. So we thought that their brain activity would be driven by the same stimulus. So to do so, we computed similarity index between the participant A and B using this formula. So what this formula basically tells me that, let's say you're reading a book and I'm walking down the street. Since I'm describing our brain activity with only 4 patterns, sometimes by chance we will have the same brain activity pattern at the same time, although our brain activity is completely independent. So this similarity index tells me how much more similarity we have between your brain activity and my brain activity compared to if our brain activities were completely independent. So we compute the similarity index between each pair of individuals, and then we take the average per participant. So here, for example, it tells me how much on average my participant 1 was synchronized with the other members of their group. And we, of course, compute these metrics for the 3 conditions. And this is what we get. So you can see that for the resting state and scrambled, the similarity indexes were around 0, telling me that the participants in these groups were as similar as they would be if their brain activity were independent. But we can see an increased similarity in the movie condition, which was significantly different than the 2 other conditions. And finally, we wondered whether we could track the inter-subject synchronization with the characteristics of the movie. So we showed participants a Hitchcock movie, which is very suspenseful. So we thought that maybe during the scenes where the suspense is very high, maybe we'll observe some more synchronization compared to other scenes. So to check this, we had 15 participants who rated different scenes on a scale of 8, and they decided how suspenseful was the scene. So the movie was cut into 2-second segments, and at the end of each segment, participants rated the suspensefulness. And then we took the moving average of 7 segments to get rid of the noise. So here I'm plotting the suspense on average suspense rating. So you can see that actually it fluctuates in time, it varies in time. There are moments that the suspense is very high and the other moments the suspense is quite low. And then we used entropy as a measure of brain activity co-occurrence. So we computed entropy at each time point, so at each TR, using the probability distribution of the different patterns. So when the entropy is low, it actually tells me that at this time point, I have more participants having the same brain pattern. And when the entropy gets higher, it means that we're going towards a uniform distribution. So when we look at it, actually, it seems like there is a relationship between suspense rating and the entropy. We can see that when the suspense rating is high, it's actually followed by a lower entropy. And it seems like there is a little lag. It's a bit shifted in time, which kind of makes sense because MRI has a very low temporal resolution. So if I present a stimulus, it would take me at least 6 seconds to observe its effect because it would take 6 seconds on average to both signal to reach its peak. We then computed a Spearman correlation between suspense rating and the entropy by taking into account this 6-second lag. And we found a very significant negative correlation between the entropy and the suspense rating. So overall, this results actually suggest that higher order processing can influence the ongoing brain activity. And by looking at the characteristics of the perceived information, we can actually track the inter-subject synchronization. So this is all I wanted to tell you today. If you have any questions, please do not hesitate to write me on Discord. And thank you for your attention.